Well, hello again. Yes, it's me, and I'm finally back with our radio. I know it's been a while, but you know, there's been a reason for that. And we're going to go ahead and start this video out. I'm going to teach you something, and I want you to pay attention. Normally, I just show you how I do things, and you can utilize those procedures or come up with your own. It doesn't matter to me. I just, at the end of every time I finish a series, I say this is the way I do it, okay? Meaning there's millions probably of other ways to get the job done. So you come up with your own, and you of course are always expected to do better. However, today I'm going to teach you something, and I want you to pay very close attention. The newbies, the ones that aren't haven't been in the hobby that long. The old timers know this. They know a lot of things that I haven't even come close to even showing. Actually, what we have here is a piece of wire. Okay, now this is a 14 gauge wire. Now this wire can handle so much voltage and so much current, just like any other wire. It can only handle so much voltage and so much current. So what happens if you exceed that? Well, you'll burn through the insulation, or you will fry the entire wire, to include, the center conductor, the copper wire. Well, what determines how much voltage and how much current that a wire can handle? Alright, the voltage limit of a piece of wire is determined by the type of insulation on it, the quality of the insulation, and the thickness of that insulation. Okay, if you have very thin insulation, voltage comes down. If it exceeds the rating of the insulation, it will blow right through the side. It will melt it. It will blow right through the side. And if you're hanging on the wire like that, it's going to blow into your hand. Okay, simple as that. Everybody knows that now. Of course, we don't see that with wires generally of this size, but you've seen big wires where somebody's been electrocuted. The electricity has gone right through the wire, gotten into his hand, or any part of his body. Some of those linemen, those electrical linemen, that sort of thing, have even been killed by that sort of thing, where it's blown through the insulation. Type of insulation, quality of insulation, thickness of insulation determines how much voltage the wire can handle. Well, what about current? How many amps we're talking about? It's the cross section of the wire. How thick is the wire? Cross section meaning, you got round and then a cross section, all right? The diameter of the wire. The thicker the wire, the more current it can handle. The thinner the wire, the less current it can handle. I had a guy one time contact me, it's been a couple of years now, and he said, hey, look, I'm working on my radio, and I need some wire. Can I just go down to Walmart and get some? He said, they got it over in the automotive section. Well, I told him, no, you can't do that, Take a look at that wire. So I think the maximum rating on that stuff is only 18 volts. And your radio's got 300-400 volts, 500 volts. You can't just go down to Walmart and get some thin wire that can't handle any current, can't handle any voltage, And he wrote back and said, geez, I never realized that. Wow, I was going to stick 18-volt wire in a 300-volt chassis. I said, yeah, that's right. Don't do that. Get the right size wire for the chassis. Now, I get all my hookup wire from Radio Days, and it's rated at 600 volts. I had to call up one day, and I said, hey, look, they had a new kind of wire they were offering or something. And I called up and I said, hey, is that wire still rated at 600 volts? Well, the lady on the line said, well, I think so. Well, what do you mean you think so? No, we don't need think. We need to know, is it still 600 volts? So she said, well, I just think so. Well, I sent an email, and they double-checked and everything. And yes, it is. The hookup wire they offer on Radio Days is 600 volts. But they don't have a current rating on it. I don't think they even list the voltage rating, which they should. But they don't have a current rating on it. Keep in mind, cross-section of the wire in the center determines current. Type of insulation, thickness of insulation, quality of insulation determines how much voltage it can handle. And now that I've told you all that, I have taught you something. I consider myself a teacher. Yeah, okay, I'm not really. But you're going to see where all of this is going to come into play. Here's our 47 tube, and as you can see, it's glowing real good now because I got these two tubes out. Now we'll go ahead and we'll stick in the 24 over here Try and get the thing lined up right. Keep your eye on the filament here. There we go. See how it dimmed? I'll give it a few seconds. As this one's warming up, this one stays dim, see? Now we'll take out the 24. That was the second detector, by the way. And now we'll put in the, I think that's the second detector. Yeah, this is the AVC tube. Now this one's a 24A. And I couldn't find a whole lot of data on it, but I assume it's the same thing. Alright, now we plug the 24A in. Look at that, jam, almost puts it out. Almost puts it out. So that's our problem. This is the 47 tube, 1.59 amps. I'm going to test these things individually, then I'll put them all together. This is the 24A. Here's the 24 tube. Now we're going to hook all three together and see what the total current draw is. It should be somewhere up around a little over 5, maybe 5, a little over 5 amps. Alright, with all three tubes connected in parallel, we're reading AC current. And that's not enough, guys. We need at least 5 amps. So now I need to disconnect the tubes until it finally jumps up. I think we have a bad tube filament. I disconnected the 47 audio output tube, and this is what we have. We should be getting about 3.5 here. Let me see. Yeah, about 3.5. We're pretty shy. The 24A has been removed and the 47 reconnected, so I have these two in parallel. This is what we're getting with those two. It's possible we have two 24 tubes here that are bad. Now let's go ahead and put this one in here and remove this one. Well, the 24A is now in the circuit and we have no glow at all on the output tube. Let's put this other 24 back in. And we're only reading 2.6 amps. Alright, the 24 is in now, and this is our current draw. AC amped, remember. And we are still not getting any glow out of our output tube. However, you know, just like the other 24, we're getting a slight glow out of this one. So, let's hook it directly to the 47 tube again. Just with the 47 again, we have a glow, although one side is a little weaker than the other. I don't know, that looks like a double filament in there. After some discussion with Brendan, my electronics mentor who lives up in the Detroit area, he came up with the idea. He said, you know, it looks like the tubes are pulling down a weak winding in your power transformer, and the power transformer in this radio, you know, was burned when I first got it, so you know, it sounded logical. It was acting that way. It just couldn't handle the current load. So what I told him, I said, well, I've got this brilliant idea. I said, why don't we take the power transformer that's in there now, mount it in the cabinet, and wire up everything. You know, there's plenty of room in the cabinet because this is a floor model radio. I'll just use the windings in that power transformer that are good, and then we can go ahead and buy a filament transformer and just mount that on the chassis, or we can mount, you know, leave the power transformer in, mount this on the chassis, and just use a filament transformer to operate the one winding that's weak. But I said, you know, mounting the power transformer on the cabinet would be okay. There's plenty of room in there, no problem. Why don't we try that? Well, he sent back a song. Well, I didn't have to be hit on the head to take a hint. He didn't like that idea at all. He said it was Mickey Mouse. So, So he said, look, go buy this transformer here. It's rated at 10 amps, got a center tap and everything. And then just find a place to mount it. Leave the existing power transformer on the chassis. Okay, so I went ahead and did that. And this is it. This is a, what do they call this thing? I don't even know what the number is. There it is. You'll have to read it for yourself, I guess. Got it from Hammond. I ordered it through the Antique Electronic Supply, or what they call Tubes and More. I usually don't order anything from those guys. Their prices are too high, but this one here, the price was okay. And you know, the mother of necessity, you know, gotta have what you gotta have. So this is what we'll be using the rest of the way, I hope. Let's stop here and take a look at the schematic before we go any further. This is the B winding I'm talking about. It's a center tap. Yeah, it puts out 2.5 volts, and it feeds the 24 tube. This 24 tube here, see the letter B, this is for, you know, those who have been following this series know all about this. And of course the third tube is B, is the 47 tube, but this has a filament. See here? There's no cathode. It's filament and cathode. It's a heater and cathode combined, directly heated cathode, I guess is what they call it. And this would be, this has a cathode with a heater. So this is actually a heater. This is a filament. One of our subscribers said, why don't you just take a wall wart, 9 or 2.5 volts, and just hook it up and that'll work. No, it wouldn't, because we're running 1.75 amps per tube, which comes out to over 5 amps. Can you imagine running 5 amps through one of those wall warts? Well, I would fry it up and melt it down to a blob, okay? Not only that, we need the center tap. Some people said, well, just get a filament winding transformer. Well, you can't get any one. You have to have one that's got a center tap. The reason being is this center tap is bringing negative voltage in right here. And it's coming from, pay attention now, this is important, it's coming from, let me see, did I get that right? Yeah, it's coming down, it's coming from the center tap on our high voltage winding on a power transformer. Negative voltage is being supplied right here, negative AC. And no, actually negative DC. Negative DC voltage is coming in right here. These are your two output voltages, which are 2.5 volts AC. So, you know, this presented a question for me. I checked with Brent and I said, wait a minute, how can you mix AC and DC at this point right here? And he said, well, believe it or not, it does mix. They both go down the same wires. The DC will come in here, the AC will come out here, and they will mix together. Well, so I said, well, what's the deal with that? Why would you want to do that? He said, it's very simple. The AC voltage lights the filament up, makes it glow. The DC voltage puts bias, negative bias on this cathode. It's a cathode and heater combination. Remember that? He said that pretty much falls into the category of, what did he call that? Multiplexing. Or what we used to call in the military years ago, muxing, M-U-X-I-N-G. So anyway, I knew something about it, but I didn't quite realize it would apply here. So that's why you have to have this center tap. We needed a DC to bias this cathode heater combination called a filament, okay? Just can't use any old, you just can't use any old filament transformer. All right, back to the filament transformer I bought. This I hooked up to the AC voltage coming in. This is our primary. And I connected this and this. The striped one here is the center tap. And that was only going to be used for bias. Remember that now. These two here are what lights the filaments, or the heaters. Heaters in some tubes, filaments in the others, that in the 47 that I showed you on the schematic. So we went ahead and hooked it up. Nothing. I spent the money, went through all the time and effort. Same exact problem. Plug the tubes in, get them in there, and all the filaments go out, or almost out. Well, I couldn't believe it. I said, this can't be. You know, this is a brand new transformer. So, well, you know, I knew the wiring on the bottom of the sockets was correct. I mean, it's only what, 3-4 wires. Come on, no big deal. But it still didn't work. What could be the problem? I had all the I took all the tubes out of the chassis and I gator wired all the filaments out of the chassis. I thought, well, maybe it's a socket problem. Maybe I got a bad socket or something. Removed all the tubes, gator wired each of the filaments from tube to tube to tube, and then connected them to here. Nothing. Still didn't work. I said, man, I got some bad tubes here or something. So I put the tubes on the tube tester, and I don't have one of those cheaper tube testers. I've got a really good tube tester, okay, a laboratory tube tester. Everything worked fine. The filaments all lit up perfectly. No shorts. Everything was great. I said, man, what is going on here? What is going on here? Anyway, I remembered that Brendan, you know, it always goes back to Brendan because he knows so much about so many things. He's had a lot of experience in his life, and he had mentioned early on that, you know, it's possible that the wires I'm using, those hookup wires that I bought from Radio Days, could be they're not capable of handling that much current. Maybe that's the problem. Maybe it's too thin. And he just sort of mentioned it, you know, and we just kept on moving, kept on troubleshooting. I mean, there was a lot of give and take back and forth on emails and videos that I sent Brendan. And finally, it just got to the point where I was like, hey, this is getting ridiculous. I'm just tired of wasting my time on this thing. I'm just going to go ahead and order brand new tubes and everything, and we're just going to start from scratch. And he said, well, now don't be giving up on the tubes just yet. You know, let's try this, let's try that. Everything we tried did not work. And then today, which is Saturday, the day before Father's Day, I got thinking. I said, you know, old Brenda did mention that he did mention that maybe the wires weren't thick enough, the hookup wire that I put in there on the filament connectors on the bottom of those 3 tube sockets, because I rewired all brand new wire, took out that old crap, you know. So I went ahead, I had some 14 gauge wire that I had gotten out of the scrap barrel where I work, and I went ahead and connected. I just soldered that wire to the bottom of the tube pins, and then connected those wires, those, you know, the 14 gauge wires, I soldered them up right here. No gator wires, no nothing, just a direct solder from pin to pin to pin to pin, and then a direct solder to this filament transformer. Here's what happened. Are you ready for this? Check out that. That's our current draw now, way below 500. It was way up over 600 milliamps. Now, how did I do that? Well, I went ahead, I took the plunge, big boy, and I went ahead and connected all the filaments together using 14 gauge wire. Now look what we have. A very nice glowing tube, 47 output, and 2 more nice glowing tubes. Look at that baby glowing up in there. And this one right here. They're all glowing nicely now, and my current draw is down. So it was either the wire needed to be bigger, like it is now, the 14 gauge, or I fixed one of the pin solder connections in the process of connecting these wires and didn't even know it. Well, I think this problem is solved, at least for now. I disconnected the 14 gauge wires from the leads coming off the transformer, and let me get a little clarity here. And now we'll go ahead and hook her back up just to make sure everything's alright before we put the tubes back into the chassis. Alright, there we go. We've got 117 volts. We're drawing about 480 milliamps. The radio's drawing 480 milliamps. And what are we getting here? We're barely getting a lit filament. Barely lit. These over here, it was just lit a few seconds ago. Now it's not lit. Yeah, now most people would say, my gosh, I don't believe this. It was just working, now it's not working. Look at that, you can barely see that filament lit down in there. What's going on here? Well, I'll tell you what's going on here. It's these jumper wires. They're too thin to handle the current draw of these 3 tubes. These 3 tubes draw 5.25 amps total. The 14 gauge wire can handle it, but this cannot. So if I take and hook the 14 gauge wire back to this very large wire, because this, like I said, this thing here is a 10 amp, it can handle 10 amps, so it's got very thick wire. So if I connect those two back together and eliminate these thin gator wires, these things should light up again. Let's see if it happens, unless something crapped out a second time, but I don't think so. Let's try it. I have eliminated the gator wires and just spot soldered it back together again. Let's see if we have any filament glow this time around. And of course, there we have it, the way it's supposed to be. All three tubes lit up the way they're supposed to be. Okay? There you go, guys. It's proof, absolute proof, that the thin wires were not carrying the current load and were unable to light the tubes. So now what we have to do is, I'm glad I bought this second transformer. It's a little expensive, but I can always use it for something else. If nothing else, I can use it as a test, part of my test bench. Anyway, what we need to do now is disconnect these wires again and hook them over here to the original transformer. If I can get a little focus here. But see, what I did here is I took a couple of those 22 gauge wires and I hooked it onto the transformer, and then I ran them down. I wanted to extend the wires from the transformer. Well, that's not going to work. We already know that these wires will not carry the 5 1/4 amps. So what I'm going to do now is I'll go ahead and disconnect these green wires, take off these blue wires, get a little focus in here, and then solder these 14 gauge wires directly to the stubs sticking out of our power transformer. And if it does not work, then we know for sure the power transformer is screwed up, and we're going to have to find a place to mount this and start using this to work the filaments on these tubes, the B winding. Anyway, I've got it connected with 14 gauge wire, and over here you'll notice that the primary on this transformer is gator wired in. I have it gator wired to the power source. It works fine. Okay, it's gator wired. I just tapped into the 120 volt line right here and fed the primary. Works great, but when you get to the other side, you'll notice they got much thicker wires here. And when you start pulling on the current, there has to be wires, pretty much as thick as that can handle whatever. Now this thing handles up to 10 amps. We only needed 5, so about half that thickness would have worked, and that's about what we've got with the 14 gauge. So let's see what happens. We have the gator wires out, 14 gauge is all in. Now if this works, if they all light up, what that means is I'm going to have to go back in and remove all that 22 gauge wire between the filament connectors on the bottom of those 3 tubes, and I'm going to have to replace it with 14 gauge, okay? Which is no big deal, we're talking maybe 30-40 minutes here. Okay, let's hit the switch. If everything lights up, next time we'll have the chassis sitting upright, the tubes will be in it, and hopefully they'll all be lit up. So let's go ahead and hit the switch and see what happens. Come on, baby, light up. Come on, baby, light up. Oh my goodness, look at there, she's lighting up. Without the gator wire. If I put the gator wire back in, they will not light up. What have we got here? Lit up and lit up. Look at that. Well, I think we all learned something from this one. Old Brendan right in the beginning said it might be the current handling capability of the wire. Yeah, he was right. He know everything he knows. I taught him, so he did a good job on that. Next time, hopefully, we'll see this thing at least back together, making some noise, okay? I'm not going to say it's going to be tuning in a station, but it will be making some noise. Hope you learned something. Remember, some wires handle more current than others. Until next time, this is John. 16 gauge, 14 gauge, 14 gauge, 16 gauge. Brendan said I have to do this 100 times. 16 gauge, 14 gauge, 16 gauge,